Section 2.3, Introduction to Deductive Reasoning. So we talked already about inductive reasoning, but deductive reasoning is the process of using facts, definitions, accepted properties, and the laws of logic to form a logical argument. So here's the difference. We're using facts, definitions, accepted properties, and laws of logic to form a logical argument. So this is different from inductive reasoning, where inductive reasoning uses specific examples and patterns to form a educated guess or conjectures. So this uses specific examples and patterns to form an educated guess on what may happen next. And we did this earlier on when we said, we started to look at the sum of 3 consecutive integers, and then we made a conjecture after we looked at the several different patterns. And what we said is that, we started to notice that it's the middle integer times 3 that gives us that other integer. So that was our educated guess, that we take our middle integer times 3 and it gives us our sum. But in order for us to actually prove it, or we'd be using deductive reasoning, is what we showed when we said, if n is the first number, then n plus 1 is the second number, and the third consecutive integer would be n plus 2. And our conjecture was that we take that middle number again, right here, multiply it by 3, and that should give us 3 times that middle number. And that's deductive reasoning. That's using accepted algebra properties, because now when we take our like terms on the left side and add them together, we get 3n, and we get 1 and 2 added together gives us 3. That is the same as taking 3 times that middle number using the distributive property, and we get 3n plus 3. So that's kind of the difference between inductive and deductive reasoning. So now let's take a look at one other thing that we're going to study in this section, and that is the law of syllogism. And we're not going to specifically work with that today, but the law of syllogism is logic chains. Okay? So that is multiple conditional statements that are all linked together. So they're linked together, they're related, and we can come up with a valid conclusion that way. And again, that we'll be talking about that later. You can do a lot of silly ones, but if you say something like, if my parents give me $10, then I can go to a movie. If I go to the movie, I am going to get COVID. And if I get COVID, I'm going to have to stop playing my sports. And so your logical conclusion in order would be, if my parents give me $10, then I won't be able to play my sports anymore. So again, that's a logic chain. We'll look at that later. So let's just take a look really quickly at using inductive reasoning to make a conjecture. So when we use inductive reasoning to make a conjecture about the sum of a number and itself, we first start looking at specific examples to kind of see what's going on. So if we take a number added together with itself, we try to look for a pattern. And maybe you start to realize that the sum of a number and itself is really just 2 times the number. So we can look at this and say, I think it's the number itself times 2, and that seems to work. Okay, so if we take the number itself times 2, we get the sum of those 2 numbers. So our conjecture would be the sum of a number and itself is twice the number. Or you could say the number times 2. So that's our conjecture. Now to show it, okay, this was our inductive reasoning part. So this is inductive reasoning. And now for deductive reasoning, what we would do is we would say something like, let n equal any real number. Then we would have n plus n, n plus, so the number plus itself is equal to twice the number, so 2n. And that's how you write twice the number. And that's 2n. Well, again, using our properties of algebra, n plus n is 2n, so we get 2n equals 2n, and so it is true. We have proven it using deductive reasoning. So that's just a little sort of information and trying to help you understand the difference between inductive versus deductive reasoning. And so if you look at these examples and you try to determine whether inductive or deductive is used, you have to determine whether you're basing it on observations and specific examples or facts. So let's look at this first example. It says, decide whether inductive or deductive reasoning is used to reach the conclusion and why. All reptiles are cold-blooded. Parrots are not cold-blooded. Sue's pet parrot is not a reptile. So this would be deductive, because it's using facts about reptiles. Those are accepted facts about reptiles. Okay, if we look at the next one, okay, it says, every time Tom has eaten a strawberry, he has gotten a rash. The next time he eats a strawberry, he will get a rash. So now we're using inductive reasoning. There's no accepted properties or facts that if you eat a strawberry, you get a rash. But he's using specific examples over time of what's happened in the past. So specific examples about what has happened over time. And then the last one, why don't you take a look at that one and see if you can determine whether or not it is inductive or deductive. And sometimes it might be either one depending on what you're using. So give that one a try, and then you can check back to the notes to see if you got it correct. But this is the end of our introduction to 2.3.